A global financial institution transfers a large aggregate data file every evening from offices around the world to its Hong Kong head office. Once the file is received, it must be processed in the company's data warehouse. The time T required to process a file is normally distributed with a mean of 90 minutes and a standard deviation of 15 minutes. So immediately we can write down T is a normal, 90, 15 squared. Remember, this is the variance here. An evening is selected at random. What is the probability it takes more than 2 hours to process the file? 2 hours is 120 minutes, so we're asked for the probability T is greater than 120. That's a standard normal CDF on the calculator. 0.0228 is the probability. It was actually 0.02275, and I'm going to use that slightly more accurate figure in the next part of the question. What is the probability the process takes more than 2 hours on 2 out of 5 days in a week? 5 days in a week? That's a fixed number of trials. That tells me we're now using a binomial with 5 trials and a probability of success of 0.02275. Probability y equals 2. That is a binomial PDF on your calculator. And so we get 0.00483. The company is considering outsourcing the processing of the files. A quotation for this job from an IT company is given in the table below. Complete the table. So, what we want are the probabilities. We already worked out that this one is 0.02275. Now, think about it. The mean was 90. This is more than 120. This is less than 60. That's the same distance. We know that the normal is symmetric. I mean, you could just go and work them out using your normal CDF. So, if we know that 120 up there, the 60 down here, that's going to be symmetrical. So that one's also going to be 0.02275. And then 1 take away those 2 gives us 0.9545 in the middle. What is the mean cost? So we want just the expectation of C. That is going to be 200 times 0.02275 plus 600 times 0.9545 plus 1200 times 0.02275. That gives us $604.55. Calculate the standard deviation of the cost. Now I always do this by doing the fact that var C is going to be the expectation of C squared, take away the expectation of C squared. So, expectation of C squared would be 200 squared times 0.02275 plus 600 squared times 0.9545 plus 1200 squared times 0.02275, and that gives me 377290. Take away the 604.55 squared, gives me 11809.2975, and so the standard deviation is just the square root of that last value, and that gives me $108.67. In the following year, the cost, currently Y dollars, will increase due to inflation and also the introduction of an additional fixed cost. So the new cost, N dollars, is given by N is AY plus B. In terms of A and or B, state the mean cost in the following year and the standard deviation of the cost in the following year. Okay, so, well, the expectation of n is just going to be a times the expectation of y plus b. So the mean is affected both by adding and by multiplying. So that is going to be 60455a plus b. Whereas the standard deviation of n is just going to be a times the standard deviation of y, because adding doesn't affect the spread of the data, and so that is going to be 108.67a.